explain what credibility is. It's just dictation that's a little boring. For example, here are several devices. Draw a little more average. I draw a few more. For the above equipment is connected like this. The following devices are connected like this. Now write a network segment here on the right device. Still 1.0 network segment. Now run the RIP protocol between all devices. It selects the optimal path based on the number of hops. If R1 visits R2's 1.0 network segment in the future, how many roads are there? Okay. There are 2 roads. So which of these 2 routes does it take? Assuming the above 2 lines are 10M. The following 2 lines are 10G. I wrote bigger. In this case, it can show the disadvantage of RIP protocol. At this point, you will definitely think that this traffic wants to go the following route. Although the above line passes through less equipment, but it's only 10 megabytes. And the following is the 10G link. But unfortunately, RIP selects the optimal path based on the number of hops. Data goes to network segment 1.0. It takes 3 hops to take the above line. If you go down, there are 5 hops. So the following line is bad. The data will choose the above line. The above line looks like a path. The line below looks like a big road. But when the data is actually forwarded, the speed between the 2 of them must be the one below. There are many routers in the middle. Actually take more time. Mostly due to the time for device lookup table forwarding. The device has received data. It checks its own routing table and forwards. This time does go through one more router. Just check the routing table once more. That will be relatively slow. The above is 10 megabytes. Below is 10G. One flow every time. Go here to check the time spent in the routing table. Due to inconsistent link bandwidth, have an overall impact. So for RIP, it is a completely wrong protocol. From the selection of the optimal path. So there is no way for it to continue to be used. The current overall processing age is a bandwidth supremacy. For us now, bandwidth is so important. Now it's all 10G lines. You're a fool to use 10 megabytes. So now this thing is useless. This is called low confidence. Next. There is another sentence. They exchange information by periodically broadcasting the entire routing table. Of course, RIP uses broadcasting in a version. It also improves. Let's look at this routing table first. Actually, RIP is the routing table for delivery. It would be better if the overall network environment is small now. If the network environment is particularly large, it means that the routing table of each device will be very large now. If the equipment is updated periodically, just keep passing the routing table back and forth. I will give you a simple example. Everyone must be clear. Traffic problems during network data forwarding. Suppose now multiple devices. They are connected to each other. What we are talking about. Running OSPF, RIP, EIGRP, etc. These things are dynamic routing protocols that generate routing tables to run messages between them. That is all the content that is interacting in it now. Just to generate a routing table for each device. It is only called traffic inside the protocol. The reason we build the network and run the protocol is to allow these devices to communicate with each other and learn the network segment behind. Learning their respective network segments is for let these terminals and some servers behind the network segment. Let these various devices communicate with each other. Routers are only used to forward data. So theoretically the information data transmitted in the link. The data used to generate the routing table should not be too large. For RIP, it updates the routing table every 30 seconds. On this link, routing tables are sent between them every 30 seconds. Then this link has been running. Used to maintain neighbor relationship. These traffics include update routes. It will not be able to run so much normal business traffic. Business flow is. Now here is a host. It wants to access a router behind this device. Traffic also goes along these lines. We call it business traffic. We build networks to run business. Then in the network, there should not be particularly frequent traffic exchanges other than business on the link. This is an occupancy issue of link bandwidth. So for RIP, it either selects the optimal path overall, or the way it routes updates are very unoptimized. So it's now obsolete. But there is also a BGP written here. When we talk about OSPF later, let me tell you about it again. In fact, strictly speaking, it is also not a full distance vector routing protocol. It has another name. This protocol runs on the public network. We don't see BGP internally. It is used to run between different AS. For example, if your company is a very large company, to connect with some operators, BGP may be running in the middle. Including carriers may run BGP between. It belongs to an external routing protocol. Next, let's talk about the algorithm of the link state routing protocol, called link state, called LS. A typical link state protocol is OSPF, ISIS. Cisco does not seem to talk about SS, because it is a carrier technology. We will speak OSPF. It will have an NA, NP and IE stages. It's just that the depth is different. For these two routing protocols, ISIS, you just need to know this stuff. They all use the SPF algorithm. It's just that the way it's done is different. You'll think it's pretty much the same inside. But ISIS will be more optimized. It is also stronger than OSPF. Here are some differences between them. The biggest difference between link state and distance vector is that what is sent between them is not the routing table. Instead, link state is sent. This is what I told you. Distinguishes whether it is a distance vector or a link state. It depends on whether it interacts with the routing table. EIGRP interacts with a routing table. So it's a distance vector routing protocol. For link state, let me just expand it for you. The link state is like an OSPF protocol is running between the two devices. Assume that the device on the right has a network segment of 1.0. Then as long as the device declare this interface into OSPF, a link state is generated, called LSA. Then this link state is not a routing table. If you wish to generate this state, the device on the right will be passed to the device on the left. But it is not a table. After it receives this information, if it wishes to form a table from this information, it needs to pass the calculation of the SPF algorithm in OSPF. That's what we're talking about. An algorithm of shortest path first. After this algorithm is calculated, form a table locally. I will give you an example. Link state routing protocol. Like giving you some ingredients. If you want to eat, cook for yourself. Distance appetite.